Okay, so we're going to have a look at some difficult quadratic nth term rule questions. So here we have a sequence. Now, if we know it's a quadratic nth term rule, or we know it's an nth term rule of some kind, we will start with the first difference for the first two times. So from 0 to 0, we're adding nothing at all, and from 0 to 2, we're adding 2. And then we have a look at the second difference. So if we're adding nothing to adding 2, then that's an increase of what we're adding of 2, adding 2 more. Now let's just check that second difference is constant, and therefore it is a quadratic nth term rule. So from 2 to 6, we're adding 4. And so from adding 2 to adding 4, we're adding an extra 2. And that's what our second difference is showing. It's constant. We're adding 2 more now on our second difference. Therefore, it's a quadratic nth term rule. And we need to compare it to n squared, or at least a multiple of n squared. Now, so n squared is the most basic quadratic sequence. 1 squared, 2 squared, 3 squared, 4 squared, and has the rule n squared. Now, you might already know this, and if you do, you can skip this step. But the rule n squared has a second difference of plus 2. If you didn't know that, or you weren't sure, you can work it out. So plus 3 plus 5, the second difference is plus 2. Check. From 9 to 16 plus 7, second difference, plus 2. And what we're seeing here is that this sequence that we don't know has the same second difference as this sequence that we do know. So it involves n squared. How many n squared? 1 n squared. So we're just going to compare it to n squared directly. If you know that n squared, as I say, has a second difference of 2, we don't need to find it out, we just know it. So the next step is to find out how different our unknown sequence is to our known sequence n squared. All right, well, how do you get from 1 to 0? You take 1. How do you get from 4 to 0? You take 4. How do you get from 9 to 2? You have to go from the known to the unknown. How do you get from 9 to 2? You take 7. It's not fitting very nicely, is it? But that's okay. How do you get from 16 to 6? Well, you take 10. Now, taking 1, taking 4, taking 7, taking 10, well, that is a sequence. Have you spotted how it's changing? We're taking 3 each time. And if you're taking 3 each time, you only need to do it twice to know that it's the same the third time. If you're taking 3 each time, then this has an nth term rule of negative 3n, because it's like the negative 3 times table, except clearly it's not the negative 3 times table. That starts on negative 3, but we start on negative 1, which is 2 more. So this sequence has the nth term rule, negative 3n plus 2. Now, let's not lose sight of the fact of what we've just done. We have found that this sequence here, n squared, combined with this sequence here, negative 3n plus 2, makes this sequence here. Just look at it. 1 and negative 1 is 0. 4 and negative 4 is 0. 9 and negative 7 make 2. 16 take 10 is 6. Why did I not carry on and do the 12? 12, well, you know what, 4 terms is enough to give you 5. So, looking at the nth term rule bits we figured out, n squared take 3n plus 2, you combine those and you have the nth term rule of the sequence. Let's look at a hard one. So, we're going to do exactly the same thing here. In the beginning, we're adding 10, we're adding 16, second difference, we're adding 6. Now we're looking for that and add 6 again, just to be really sure that we've crunched everything correctly. So what are we adding here? 22. So yes, second difference is plus 6. Now, if the second difference is plus 6, I can find out how many n squareds I need to compare it to by halving. That's how many n squareds we need to compare it to. We need to compare it to 3n squareds. I do not like calculating 3 lots of this sequence on the fly, so I write it down first, and then I can see the numbers that I'm tripling. 27, 48. So that's 3n squared. And I do this, I write it down to make my life easy. I don't want to conjure the n squared numbers in my head and triple them on the fly. That's horrible. Write down n squared, then triple it, dead easy. Now let's find those differences, shall we? So how do you get from 3 to 3? You're adding nothing. How do you get from 12 to 13? You're adding 1. Remember, you go from the known to the unknown. How do you get from 27 to 29? Well, you add 2. That's enough, really. You're adding, so 0, 1, 2 is a sequence. What sequence? Well, let's look at the first difference. You're adding 1. You're adding 1. Now, if you found that these didn't agree, then you've made a mistake up here, right? With somewhere earlier on with your calculations. But we've got a constant first difference. Therefore, we need to compare it to the sequence the way you add 1. Well, that's just 1n. Or n, right? It's the 1 times table. But there's actually no harm in writing 1n. That's still valid if unconventional. But the 1 times table doesn't start with 0. It starts with 1. So we're different. How different? Well, you need to take away 1. So this is the sequence 1n take 1, or, n take 1. So put those together as before. This has the nth term rule, 3n squared plus n, because n is positive here, right? Take 1. There we go. And now, an even harder one. Certainly unpleasant seeing decimals in a sequence, but let's have a go all the same. Apply everything we learned so far. So, we're adding 1.5. We're adding 2.5. All right, what's that second difference? Well, we're adding an extra 1 to go from 1.5 to 2.5. Let's check. So here we're adding 3.5. Yep, that second difference is still the same. All right, if our second difference is add 1, we need to find out how many n squareds we need to compare this to. Well, remember, the sequence n squared has a second difference of 2, 1n squared, second difference of 2. So we just need to half our second difference to figure out how many n squareds we have. 1 divided by 2 is half, right? Or 0.5. That's how many n squareds we're going to compare to. So write down the n squared sequence of square numbers. 1, 4, 9, 16, that's n squared. I write it down so I don't forget. Then I half it. Now, these are decimals, so I'm going to write down decimals. It's going to make it easier to compare. 0.5, 2, 4.5, 8. So that's a half n squared. Let's find some differences. We're adding nothing at all. From 2 to 2, we're adding nothing at all. From 4.5 to 4.5, look, we're adding nothing at all. Well, just look, if we're adding nothing, then this must be the sequence half n squared, right? because you could say, oh, well, you're adding nothing, so it's the 0 times table, 0n. Yeah, but 0n is nothing, right? So we're done. Done, finished.